Okay, cool. I think we're good. We're good to go. Um, you know what? I was going to start with this work on this question. I might want to do different work. I think yeah. I want to set this up differently. Um, so I'm gonna lambda sine t dt. I'm gonna take this as the real part of the integral from 0 to pi e to the I lambda sine t dt. And this is the integral that I want to work on. If I let t equal x plus iy, how do trig identities work again? Sine of something plus something. Sine, cosine, plus. Okay. It's equal to sine x cosine y iy. No. Yes. Yeah. Sine iy cosine x. And this should be cosh. This becomes e to the minus, that becomes e to the... Okay, yeah, so that is cosh. This should be I cinch? Thunder? I hope you've been good. Holy crap, it's been a minute. Becomes minus e to the y plus e to the minus y over 2i. Oh, adds, okay. Hey Thunder, I hope you've been good. It's been a minute. Is this I'm getting like minus cinch, aren't I? You know what? Wolfram Alpha can figure this out for us. Why am I deriving this myself? It is just I cinch. I don't know what I was doing wrong there, but Alika, thank you for the follow. So this is sine x cosh y plus I cosine x cinch y. That's what I want. Since when are we adding complex numbers to integrals? I mean, I've been doing it since like summer of last year or something. But yeah, there's a whole world of integration with complex numbers that's actually really cool. In this question, I'm trying to get an approximation for a real integral. And we can actually get an approximation for this using complex variables and some other tricks. You know what? I shouldn't do 0 to pi. I should do it on some contour C. Sinh y. D... I guess I'm going to say ds, because I don't know what else to call it. Maybe it's still dt. I don't know. Clonk. This life is yours. Some of it was given to you. The rest you made yourself. Ooh. It's not a bad fortune. Hope you're doing well, Clonk. The control man has secured over nature has far outrun his control over himself. That's true. It's kind of ominous, but yeah. It's a little nugget of wisdom there. You know, no, I'm going to call it S. I don't like T. It's not really important. Let's multiply the I inside. Okay, so basically we're gonna have a function cosine x sinh y plus I sine x cosh y. And we want to take level curves of the real part and the imaginary part. I believe. Why is this so true for me? Yeah, that one, like, it's true, but it does feel bad. Um, so I guess let's just start by getting some level curves for the real part. If this thing equals 0, what does this world look like? Gonzo, do I want to do AP Calc? Looking at this, also, hey Don, what's up? I have to leave in a sec. AP Physics test on Monday. This is not AP Calc. This is way beyond AP Calc. This is graduate level math. There are integrals in AP Calc, but you're not going to be doing integrals like this. But thanks for popping in and saying hi. Something found of the Roswell crash? Okay. See ya. This is kind of meaningless, isn't it? Like, neither of these are generally 0. Hey, Valalu. Welcome in. Okay, so if I forget about the level curve for r equals 0, I guess. It has? Honestly, I can't even remember what I've changed. But thank you. I believe inverse sinh, that should have a definition with natural logs. Oh, that's disgusting. Honestly, there's so much that I'd like to make better about my stream. I just haven't had the energy to do it in a long time. But uh, what I have now isn't that bad. Okay. So if we solve this, um, oh yeah, um, oh god, yeah, it really has been a minute since you've been here last. So yeah, I moved from California to Washington State because I'm going to grad school now. I'm a master's student for applied math. But yeah, the flag was like the most like when I first moved, I didn't have the flag put up, and that was like the most requested thing for me to like get back in the background. Dude, this sucks to draw level curves of. Um, because it depends on the interval. The staple for the Don does Don factorial channel. Yeah. Does Desmos do implicit functions? I can't remember. If I give it sinh y equals minus secant x. Ooh, it actually does do implicit functions. I don't think we need to differentiate for what I'm trying to do here. And Slim, thank you so much for the raid. I hope your stream was good. Hey, $10. I was just thinking about you. I feel like it's been a minute since I've seen you around. I hope you've been good. Zach, hey. I was working on both Zach, you, and Slim. And Slim, that one linear algebra question you were working on kind of intrigued me, and I was trying to figure it out, but I didn't get very far, so I didn't end up saying anything. Yeah, Zach, and I saw you talking about Hilbert spaces and other types of spaces, and then I went to go do something, and I came back, and what were you doing? Oh, PhD's analysis question. That was a good one. Whoa, why are they dancing? Space. Yeah. This is what the hell? I don't know why they're dancing. Oh yeah, is that what everyone was talking about? Um, so yeah, this is what the problem that I'm working on right now at the top of the screen. Now, there's a really good method to do this problem called the method of stationary phase. And if I scroll up here, I solve the entire problem using basically 3 lines of math because it's just plugging into a formula. And this is the good way of doing this problem. We have been explicitly instructed not to do it this way, and instead to do it the very difficult and tedious way. And so, since that news just came out yesterday, I'm trying to figure out the long and tedious way, which is method of steepest descent. Get that hashtag rolling. So yeah, the first thing I'm trying to do to figure this question out is to... So this is a real integral. But we're gonna use it. We're gonna use complex numbers to get an expansion of it. Quit. Hope you're doing good, dude. And so for the first step in using method of steepest descent is to let your variable be a complex number, variable, and then whatever's in the exponent here, we're gonna draw level curves of the real part and the imaginary part, and the goal is going to be to deform the contour, which is originally just on the real number line. This is like our original contour. We're gonna deform it into something that travels along. The level curves with a constant. Well, I think actually with a constant I. I'll have to look at that part. 35. Okay. Yeah, Jed's had some serious streaks before. There are 35. That's some dedication. So yeah, I have an example pulled up that worked out in class. The exponent there, or like the function they were working with, there was much simpler, just t squared. And you get these hyperbolas for your level curves. And so if you wanted to do the integrals, say for like from 0 to 1, you can travel along this contour with r equals 0. So I guess we do travel along the one with constant real parts. And then along this contour with I equals 1, and then back down on this contour with r equals 1. Except you don't want this contour with I equals 1 to really be there. For whatever reason, I forget what exactly. So you're actually gonna like take this route out to infinity and show that the little bridge between these two real parts cancels out, basically. Or it goes to 0. Have you read any old math books, and what do you think about them? It seems like our professor is writing its own math book, and old ones are rarely ever used again. I have not read an old math book. Like, how old do you mean? Do you mean like Euclid's Elements old, or do you mean like 50s old? I have some textbooks that were maybe like written in like the 70s or something. Um, the more you write math books, because math changes over time. Yeah, I mean, Jed's right. Math, at least the fundamentals of math, that doesn't really change. You could argue that like the perspective on it might change, but like the information then was just as good. Oh yeah, and hey Rex, your winsome smile will be your sure protection. Is winsome a word? Attractive or appealing in appearance or character? I don't know. Apparently this place is called Winsome. 50s old. I came across math books from Polish and Russian authors from the 1960s. They're just brilliant how they didactically structure the content. Those are university level math books. Interesting. Yeah, I mean, I haven't really read, like, extensively read any older book, but, there's no reason I wouldn't, I guess. But there are some things I've been learning in my master's degree that were, like, made in, like, or, like, they're first, like, being talked about in like, the 80s. So, like, for things that I'm, doing right now, it couldn't be too old, but, yeah. Depends on the subject, I guess. Johnny has $20. How many hamburgers can he buy? 1990 answer 10, 2026 answer 0.5. That's so true. Man, what like the dollar menu at McDonald's dying? What was a sad day. Oh, you've been in Australia, Fenbox? That's why you haven't been around. Okay. How much of a burger can Johnny buy in 2100? Oh god, yeah, that's gotta be a that the change in season would probably do a number on me. Like going from like wintertime New York to summertime Australia. Um, that would be a shock. Thanos just needs to go where he could really throw a boomerang. Fair enough. Gonna sleep. Oh yeah, it will be morning for you, I think, right? Or is it? Australia is such a weird time zone to remember. I always forget. 8:30 a.m. Okay, yeah, yeah. Oh man. Okay, wait, never mind. Sunday here, right? Um, thank you, thank you. This one just uses painted black by the Rolling Stones for its starting song. But you know, let me actually scroll down the list. let's see how long it takes until a Coldplay song comes up in the queue. I'm looking through it right now. Coldplay. I don't see any Coldplay, surprisingly. Wow, I don't see any Coldplay. Maybe their most recent check didn't clear for cash or whatever. Yeah, this is Pink Floyd. It's called Brain Damage. Um, these level curves suck. From Dark Side of the Moon, yeah. You have to, yeah. I've done that like maybe only once before, and I really should do it more properly. Just change the coordinates. Is there a clever change of coordinates here? It's the closing song. Okay. Yeah, I'm just like, uh, yeah, I'm trying to draw level curves for like both of these functions here. These really are not convenient though. It's like if I take the real part equal to just one, um, what I want to do is take the inverse sinh of each side of this equation, but inverse sinh involves a natural log. Actually, oh, that's fine, isn't it? I was scared about this minus sign. But maybe that's actually okay. Wow, why is this song in this playlist? Okay, I'm leaving it, but this is such a this is such a sudden shift in tone. Okay, I want to go back to Desmos and check if this is the same thing. Also, I should check if there's a Pythagorean identity with secant squared plus 1. Okay, these are the same. Why does it look so much like secant? Oh, well, not that. Okay. But with a shift. They should be changing as we scroll to the right, though, somehow, right? Maybe, I don't know. Secant is like tangent. Eh. Secant minus tangent. The square of the number of keys on the piano? I think it's 88 keys. I have to do 88 squared? Okay, fine. I'm doing it by hand, so I'm not. I don't think I can do this mentally. 4, 6. Actually, I probably could do this mentally. It's the same. You just add two numbers. 8 times 8 is 64 plus 6 is 70. 704. 704 plus 70, 40. 704 plus 70, 40. The zeros work out nicely. 7774. Wait, no, this is wrong. No. Wait. Oh, 7744. There we go. So I hope it's 88. Number of keys on a piano. Piano. 88 keys. Noish. Keep my house and car keys in a bowl on mine. On your piano? Zach teaching? Okay, we can draw that. I was trying to do it by saying 88 times 11 squared is 64 times 11 times 11. Oh, yeah, that's a good way if you know the tricks with 11. I can never remember them. Uh, excuse me. I changed the background color. Oh, no, I didn't. Wait, did I? Yes, I thought I did. Maybe I hit cancel by accident. Okay. I guess we'll start with the background. And obviously we have to get a chalkboard in there. Unfortunately, I don't have like a fill bucket tool. That would be really nice to have here. Okay. Ooh, this is gonna look terrible. Okay. Just have to use your imagination. Um, what is that going to be working on? I'm just gonna. I saw him doing something with like a clock and a ladybug, and that will be fun to draw. Wait, how does a clock work? Wait, I don't know how clocks work. I need to listen to more Coldplay, apparently. Hey, bad. Give me the 2. Give me the 2. No, I'm clearly clicking on the 2. Thank you. Okay. 2 to the 6 times 11 times 11. 121 doubled 6 times. Ooh, that's not bad. And then Little Ladybug, kinda. This is a good song. 90 minus. Ooh, yeah. You know, what should Zach be wearing? Welcome in, Tachyon. Thank you, thank you. I just put it onto the Spotify like radio thing for Painted Black by the Rolling Stones. Okay, maybe go for like some khaki pants. Like he's usually wearing socks, I think. I don't know. We don't usually see like the lower half of Zach, so I'm kind of spitballing. But for the shirt, uh, Zach is a blue enjoyer. Oh god. Do you see the battle on The Voice Australia where they did the song? No. That sounds interesting. I want to see what's up with this. Wow, he's beatboxing it? Or a looper, okay. Is it just who sings it better? Oh, that guy's really hamming it up. Waiting for a chance to continue? Okay. He's really into it. Hey, Math Pond. Sir Severus. There's a whole book about that. And a movie, I think, right? 6, 7. It's a good one. They both have really good voices. I guess that's the end of the singing, though. Go back to the original. It's really interesting. AP, the guitar guy, had his earpiece fail halfway through the song, so he couldn't hear anything. Oh, wow. That is wild. Also, we will give Zach his tie. Also give him five fingers. 1, 2, 3, 4, 5. Okay, yeah. And then some good old Hagoromo chalk. The tie is required. No, I'm not Count Rugen. I don't know that reference. Am I playing Hangman? No, Tachyon, this is there's a channel point redeem for people to make me draw things. It's a fun little like distraction, I guess. And so Mean Machine Rex redeemed Zach or Eats a Twai Pie teaching. Oh, it's a Princess Bride thing? I've been meaning to watch The Princess Bride for a really long time. As I have not gotten around to it. We've got to think of a good thing for the tie. Wait. I feel like I should know this offhand. Zach wears glasses, right? I can't picture it now. I actually took a look at your font. I can't remember if you wear glasses. I don't know why. It is Stanley with the mustache. Okay, yes, you do have glasses. You took your glasses off for part of today's video. Okay, so I'm not completely crazy. um, Give you a little smiley face. Make your glasses blue, I guess. Why not? Oh god. These look more like swimming goggles. Actually, no. You look like one of the Ninja Turtles, almost. I forget which one has the blue headband. Okay, what should we do for the tie? Actually, I can look at what tie you were just wearing. Oh, you had a tie with math on it. That's very fitting. That's hard. That's hard to draw. I think you have a taco tie. It's also hard to draw. Oh, dude, the last stream, but before today, you had a pink tie. I want to draw that one. It's a cool tie. Okay. You have what size you used to dance ballroom like the one for competitions? Oh, nice. Wow, that's some Zach trivia right there. You used to do ballroom dancing? That was a good song. I think I have two ties, and both of them are pretty boring. Like they're not bad, but they're not fun like yours. Which side would the buttons be on? I'm gonna put them on that side. That's way too many buttons. I'll give you a belt too. You have lots of lore. I should have suspected. So that's a little low for a belt. And then give you a belt buckle, because why not? Zach also Navy SEAL. Being ineligible for the Fields Medal comes some experience. Good way to distract the judges. Okay, is there anything else we want to add here? This might be my drawing. Now it looks like Zach. Yeah, it always turns out in the end. Just gotta go one detail at a time. I guess we could give you some ears. Last I checked, Zach does have ears. I don't need to look at his... Oh, that's a giant ear. You don't have giant ears. You have normal ears. I can't draw normal ears, but... Oh my god. Kinda. Your tie is... Oh, this is a really short tie. Yeah. That's just like a chest high tie. Oh yeah, you're also holding your chalk like that. But okay, you know what? I do feel like we need to fix your tie. The tie is the most important feature here. Oh, this is the actual version of the song. I was thinking of the MTV Unplugged version of this song. That's like really good. It's still not bad, but you know, I made your torso too long. That's my issue here. I'm just gonna make your tie really long too then. I don't think that I don't think I need. Oh my god. Okay, there we go. That's slightly longer. Still not long enough, but I better fix your shoulders. There we go. Just one button now. Give Zach a mohawk? I mean, you're the one who redeemed it. We can do that. Um, and you know, it should be the same color as his tie, of course. There we go. Love it. That's a great addition, Rex. I'm gonna include that in the screenshot. There we go. Calling that a drawing. Post it in the art channel. Pink mohawk, yeah. I mean, I like to imagine that if Zach did have a mohawk, he would dye it to match his tie, whatever tie he happened to be wearing that day. Okay. Back to steepest descent, I guess. Um, I think secant squared +1, it's not anything as far as the secondary identities are concerned. E squared plus pi out of 10? E squared plus pi out of 10. Is that's gotta be pretty close to 10. I want to know what it is exactly. E squared plus pi. 10.5, not bad. Wow, I scored more than the maximum. How do you save a drowning lawyer? Throw him a rock. That's not a fortune. Okay. um Interesting. Oh. Okay. So these are different level curves is what I'm doing here with this slider. Huh. Okay. That's good to know. What's the if we have sine x cosh y equals a. This is the level curves for the imaginary part. Ooh. What a cool looking function. Why does it do this? When sine x cos y equals -1. This doesn't happen for any other value of a. Oh, or also 1. Huh. Interesting. So, I don't think we have anything to gain from considering what am I trying to say? I think we only need a equals -1, 0, and 1. That's what I'm well, ooh. Maybe you want a equals 2. Uh so what am I trying to do? We want to travel along the parts where the real part is constant, which is also the red ones here. We want to get from 0 to pi, but not like along the obvious straight line way. Okay, so we maybe want to come up on this black bar. Travel to the right on this red piece. Come back down on this red piece. And then get down to pi on that black piece. I think we need a bridge though. Okay, so we want level curves for -1, 0, 1, 2. Let me work out what this one is so it's not implicit. Because I think Desmos is maybe having a hard time with the implicitly defined function a little bit. Ren, thank you, thank you. Hope you're doing well. -1. Okay. Oop. Wait, I forgot my square root. Cut, square root, paste. Why does that look different? Sinch or sine x cosh y equals a. Oh no, it doesn't look different. I see. Oh. Okay. Huh. All right. Oh, we do need to check something else with this. So if we're traveling along, say, this is for a different problem, but if we're traveling along this red curve or this red line for r equals 0, um, we want to make sure, I think, well, the max of the real part was important, and but the real part is constant on this level curve. So we're worried about on the imaginary bridge that we're going to draw. Hmm. So okay, this problem is slightly different. This problem we have I t squared instead of just t squared. And so the roles of r and I get flipped. I should have been looking at this one the entire time. So I had this backwards because I was getting these two problems mixed up, I think. Um, yeah, we're keeping I. We want to keep I at constant as much as possible. Uh, Black ones are I. So we need to do a different route. Uh, Okay, yeah, so it's I need to have each of these drawn at the same time, to be honest. But I feel like it's gonna be just as confusing. Um so I need to remember, okay, you know what? Instead of this, I can draw lines for x equals 0 and x equals pi. Because we do have these as oh yeah, Ren. This would be terrible to figure out by hand. Oh my, I have technology and I'm still struggling to figure this out. Um, I almost want to open up Python and draw these contour plots. Um, okay, I think this should be enough for me to draw them by hand. I just need to like man up here. Um, like I don't need exact plots. I just need enough to figure out my route. So we want to go from 0 to pi. Um, actually, I guess we'll keep those marked. Okay, so uh, if the imaginary part equals 0, cosh is never 0. So we have vertical lines at each multiple of pi. And I'm only going to draw these two. And then if I equals 1, this is surely pi over 2, right? Yes. It's kind of weird there's a little non-differentiable point right there. Um, okay, so that should be enough for the imaginary contours. Let's look. So for the real contours, um, sinh is only 0 at 0, so why bother? Cosine is 0 at multiples of pi over 2. I don't know if we're going to need that. I don't think we're going to need that. What is 0.881, I wonder? I think we're going to need -1, and we're going to need +1. R equals -1. then at r equals +1, we have that. Okay. This is, I think, hopefully this is what I need. There needs to be certain things that work out here. But this is like the most direct route we could possibly have, I think, or the most direct indirect route, which is we go up here, bridge across on the real part, travel along the imaginary, which we like, bridge across the real, travel across the imaginary. What do we need to assure ourselves of here, though? Oh, wait. Well, we're going to send it off to infinity. It's another issue. So if we get more and more negative. Okay, good. What I want to see is like this blue curve here going up higher and higher, and that's what's happening. So we're going to draw one more. And that's... I think it's important that it goes from -1 to -2. Like, it should be decreasing is what we want. I think we might have the opposite issue over here, though. We might not need to send that one to infinity, though? Yeah, so this one... Oh, wait. Do we need to be a sneaky snake? What if we need to... So I think we want these R's to be going to -infinity. So we might need to be sneaky and like come down here, bridge over, and then come up like that. But we need to check if, like, are the R's going to -infinity down there? They are. Ooh. Actually, wait. I want to take another look at the imaginary contours. Why do we only get the upper half? There's maybe an absolute value here that I'm missing. Is it because Kosh is even? I think so. Yeah. And so when I took arc Kosh, I missed out that Y could have been negative. And I don't think Cinch has that issue. This graph is too noisy for me to figure that out. Okay, but the good news is that means we also have this contour down here. That's also I equals 1. And then we also have this contour when r is -1 and r is -2. Ugh, okay. So I remember it being emphasized that you want to travel it's like you when you do method of steepest descent, you want to travel on the contours with constant imaginary components as much as possible. But it's not possible to only stay on them. So when you do go on to a part, or like it's okay, no. Man, what are the words that I'm looking for? You want to travel on the imaginary on the contours of constant imaginary pieces, but in the direction of decreasing r. So here r goes from -1 to -2, so this is a good direction to go. And we can go up like out to infinity here, but you know, I can't draw infinity, so I'm just going to go to r equals -2. Bridge over on this little bit with constant r, and we're going to hopefully show that goes to 0 in the integral. Oh, but now when we travel on this I ooh. Is there an interior maximum to worry about here? There might be. Right here is what I'm worried about. I think that's an interior maximum. We need to worry about it. But then we get back onto this contour, we're back on decreasing R's. And then we can bridge back over and come up to our destination. This is we didn't like this wasn't an example we did that I think is going to turn out to be similar. So we're starting at A. We want to get to B. Of decreasing R. Yeah, and so I think this is the same interior maximum. The same type of interior maximum. What is this, Pink Floyd? Oh yeah. Great song. Loving it so far. I think this becomes a real song in a second. God, this is gonna take so long. This is such a big problem. Um, I think we know the contour though. So we can start to actually write out what these integrals are going to be. Okay, got black selected. I don't think black contrasts well enough. Magenta. Okay, C1, C2, C3 PO, C4, C5. Okay. The integral from 0 to 5 at 5 pi. Pi is about 5. Is equal to the integral on C1, the integral on C2, the integral on C3, the integral on C4, the integral on C5. C3 has an interior max to worry about. So what's happening on C1 in, well, yeah, okay, so on C1, actually, we'll write that bit separately. On C1, x equals 0. Y goes from 0 to infinity. Do we need to name? I feel like we kind of need to name these points. Yeah, we did kind of name them. Um, on C2, R is going to minus infinity. I and how do we parameterize this? X is going to go from 0 to wherever this like intersection point is. Can we just somehow bound it and not think too hard about it? Because it should go to 0 if we've done this correctly. The imaginary part is going to go from 0 to 1. C3 in this example is the bridge. How do we deal with the bridge here? Yeah, so we don't have to necessarily even worry about the parameterization here. As long as we can bound it. I'm just gonna, I guess, C2 and C4. R goes to minus infinity. On C3, we might need to split this up into two separate things. Honestly, okay, I want to bound C2 and C4. That sounds like a nice place to start. So on C2, I guess if we call the height A, this height down here could be like minus A or something. It's the point, I guess, 0, comma A. And the other point can be pi over 2, comma minus A, I guess. From 0 to A. So X is always 0. Well, yeah, and Y is just Y. Lambda minus lambda sinh Y. This zeroes out. dy. Okay, so hey Vasan. Hope you're doing well. I mean, okay. We don't need to worry about that yet. So this doesn't necessarily... Okay, yeah, we can bound it. We can bound it. This is... So lambda is going to infinity. On this interval, sinh is either positive or 0. So this is exponential decay. Ooh. Maybe I said this integral a little bit wrong. R is a constant. I is changing. Oh, yeah, I set this integral up wrong. So I think I did. R is constant. Oh yeah, oops. Um yeah, I set this up terribly. I think it's even 0 to 1. Well, I don't know. Let's write the other part out first. Wait. Okay, so this is the bit that's changing. I don't want to write out exactly how it's changing because that's just kind of going to be tedious. So um I think that's good enough. The point being that e to something that's purely imaginary is the modulus is always 1. Um, and this thing is constant now. So it's just e to the minus lambda sinh a times the length of C2. And so this length is going to 0. But also this thing is going to 0 as lambda goes to infinity. Or as a goes to infinity. It's going to infinity or to 0 for many reasons. But the one we care about is lambda going to infinity. C4 should be really similar. So if we can just knock that baby out. This song's a throwback. Okay, so what's happening on C4? The real part is always something that we're calling A. I guess minus A. Is that going to cause a problem? Hey, carry this gold. Welcome in. Hi from America. Thank you, thank you. How's it going? You might be slightly loud. Might just be the song too, but turn down just a smidge. Um, There's a little thing here that I'm kind of worried about. Oh no, I don't have to. Okay. So on C4, ooh, do I have to be worried about it? Which one is okay? The real part is still constant. How did I get rid of this X piece though? I think hmm, something about this doesn't feel right. But what I did for C2. I think the result should still be right. It's just how I got it. I think I need it to be a little. It needs to be a little bit more complicated. Um, I think I need to. I need to say that when y equals a, x equals something, and plug that something in. X is not just 0. And do I want... Wait, this is where the real part is constant. Yes. But shouldn't I be taking... This is confusing. I'm getting... This contour starts when the imaginary part equals 0. I think I'm getting confused with inputs and outputs, maybe. This thing that I get confused on when drawing these contours, because like these real and imaginary axes are for what I'm plugging in as the input, and these level curves are what you get as the output, and that confuses me. Or yeah, so when the imaginary component is 0, cosh is never 0. So x, in this case, is 0. Okay, that makes sense. So we do get just a 1 there. No, wait, this is still... That's only a 1 at the start, though. Okay. In the example problem we did, this a comma a, That's an input. It's a u comma v. A equals A defines any point on this I equals 0 line. On C3, the real part is constant. Minus 2 UV. The real part is always equal to minus 2 A squared? I guess it has to be. That's just okay. Kilobyte 8808. Thanks for the follow. Okay, I think I'm overthinking this. I think maybe the math that I did is fine. The real part has to be constant because we're traveling along that level curve. And I found 1 point on that level curve, so it has to be the same value all throughout. And I think that's all I need to know. On C4, this is a convenient point to find because x equals pi. And y is negative a. And then the imaginary part is whatever it wants to be. E to the lambda. So cosine of pi is -1. Since it's an odd function, so we get 3 negatives. Oh my gosh, okay. We get the exact same thing. Orange Hue, is AI any good at algebra yet? I mean, the issue is like, usually yes, but sometimes no. You can still get AI to make really like basic mistakes, but usually it's like not bad as far as I know. So it's kind of like a roll of the dice, I guess. Like usually it's pretty good, but not always. I mean, even with like harder math problems, it can sometimes like do them and do them well. It's just uh like difficult to know, I guess. Okay, so I think we've dealt with the two bridges going to 0. Um, so now we need to figure out. I'm going to save C3 for last. That's going to be the hardest one. But let's work on C1. Divide these 3 4-variable functions as a single f of x, y, z. I mean, I don't know exactly what that would mean, but like, you're basically spinning the slot machine for you to get the right answer. Like, it can do it. Um, but who knows who knows if it's actually going to do it. Like, there's a certain amount of like randomness. So on C1, x is always 0, y is going 0 to infinity. Oop, not C5, C1. This is always 0. Cosine of 0 is 1. Lambda sinh y dy. Okay. That's the number we had to contend with here. What branch of math would I like to learn more about? Immediately, I guess, like, mathematical biology and like partial differential equations. And I'm going to be learning more about those as part of my master's. But for things that like I would like to learn that I don't have time to do immediately, stuff like linear algebra, measure theory, and like functional analysis. I'd like to like get into more advanced linear algebra than what I've learned, and then like dip my toes into the other two, because they've been kind of coming up a lot in the things that I've been learning, and I'd like to at least have a start of an idea of how they work. Problem is, AI doesn't have any concept of the truth. It's just trying to guess what you want to hear. Yeah, basically. So it's hard to trust our spot when it's screwed up. Yeah. For a lot of math stuff, it'd be better to just learn like Mathematica, like Wolfram Alpha, but like the actual like language or whatever that they have behind it. Cooking pancakes for breakfast right now, Sunday morning. Ooh, pancakes are good. Enjoy. Um, can we does Watson's lemma work here? Will the new California Republic player declare independence from the USA while we in the Supreme Cali Council? Very soon, Orange Hue, we strike. Oh, there's no function in front. I think it's a trick though. Maybe. And of course, I'll be the Supreme Council chair for the new California Republic. Ooh, do I have a trick though? Yes, I think I might have a trick. So Watson's lemma wants us to have like a function in front here that's integrable, but there's no function there. We can be little tricksters though. And do a little like plus y minus y thing. In the classroom. The way you say looks from down here, anything seems possible. Yeah. It's the truth. And the point of doing this is that ooh, wait. Wait. Maybe this trick doesn't work here. Oh, no, this trick doesn't work. Not for what I was trying to do. Okay. Fooling the integrals into submission. Yeah. I'm gonna have to do a different idea, which is sinh is a monotonically increasing function. This function inside is at a maximum when sinh is 0. So this integral from 0 to infinity, most of whatever the result is going to come from some neighborhood of 0, because that's where the inside bit is the highest. And so what I'm going to do is split this integral up into one from 0 to epsilon, e to the minus sinh y dy, plus another one from epsilon to infinity, e to the minus lambda sinh y dy. And this one, this is the bit we're gonna chop off and ignore, and that's gonna make this what's gonna make this an approximation. We should show that it does go to, or we should show that, yeah, it's gonna go to infinity, I guess. We want to get a bound for this thing. So this integral, the best this function on the inside can ever be, like the highest value I can ever have, is when y equals epsilon. So it's bounded to, I mean, the absolute value isn't important here, but so it's bounded up by e to the minus lambda sinh of epsilon. But now this is just a constant with respect to the integral. I mean, I could do the absolute value bars there technically, but it's always a positive number anyway. I'll put them. Why not? So we get e to the minus lambda. Oh wait, how do we phrase this though? Because it's still an unbounded interval. Do I need to do the same thing? Actually, I was just trying to do before. I think I do. And so this E, it's still true. That the maximum value of this bit here happens when y equals epsilon. But the nice thing about this trick is that this integral no longer goes to infinity. It's the minus lambda sinh epsilon plus epsilon. Then as a result of this integral, we just get an e to the minus epsilon. The part going to infinity just becomes 0. And then this minus epsilon cancels with that plus epsilon. So e to the minus lambda sinh epsilon, which goes to 0 as lambda to infinity. And this is beyond all orders because it's exponential decay. Yeah, Ren, it's only a 1-year program though. So the entire master's is just 1 year. So I'm halfway through as of like this week. Am I liking it? It's pretty cool. Like the people who go here are really cool. I liked a lot of my professors. They go by quarters here, and like my classes this quarter haven't been as exciting, I don't think. But overall, it's still like I'm learning a lot. It's really difficult, but I've been able to keep up so far. Yeah, it's like last quarter I like my professors a bit more, but this quarter I do have one professor who's probably been my favorite so far. It's just my other two are I'm kind of met on. Yeah, and so one of the things I'm really interested in is mathematical biology. It's called. And so I guess I can answer both these questions at once. So what I'm taking this quarter is so the question this is the problem I work on right now is a homework question for my advanced methods for ODEs class. We've hardly solved any ODEs yet, but it's I would probably, if I were to rename this class, I would call it asymptotic analysis, because we're halfway through the class and haven't done a single differential equation. Well, okay, no, we've just started to do them now. And this is like one of the core classes that you have to take, but I'm being a Giga Chad nerd, and there's, for the core classes, you can choose to take them at the master's level or the PhD level, and I'm, despite being a master's student, I chose to take them at the PhD level, so this is like the harder version of this class for the same requirement. The class was supposed to be easier. It's about like chaos and dynamical systems, which I was really interested in too, but it doesn't look as impressive on the transcript. Actually, I'm more interested in that, but again, it doesn't look as impressive. I'm in mathematical analysis in biology, which is a lot of difference equations and ODEs, so differential equations. And then my last class is scientific computing with data. So we've been doing like it's gonna be a bunch of things, but we've done Fourier transforms, wavelet transforms, and we're just getting into principal component analysis now. You might also enjoy new book, Probability Zero, Mathematical Impossibility of Evolution by Natural Selection, the Math of Evolution. Really? Mathematical Impossibility of Evolution by Natural Selection. That's a interesting argument. Probability Zero, the Mathematical Impossibility Evolution by Natural Selection. And so yeah, last quarter I was in applied complex analysis. Something also mathematical biology. And then just regular scientific computing, which is about numerically solving differential equations. So yeah, I don't know. Like these two classes have been so similar to these two classes that like I felt a little like not like I guess like repetitive. Like the scientific computing class actually is a lot different, but it's still like I wish there was a more variety in classes, I guess. I'm trying to find a little oh, I'm not looking at Grokpedia. Plant network science. Not specifically. Let me. There's one class that might be related to what you're talking about. I'm trying to remember what it was though. Because I'm disappointed that I missed out on this series of classes. But there just wasn't enough room in the schedule. Okay, yeah, so there is a class on that includes networks. I think this is the one that I could have taken last quarter, but I didn't because I just didn't have enough room. So like it would be cool to learn about this too. I think this is what you're talking about. I heard he claims the rate of DNA change required for evolution to lead to humans is way too fast to be statistically possible. Really? Turn on maple syrup? Oh no. Kim? Thank you so much for the raid, Kim. Welcome in, people. Devno, thank you for the follow. I hope your stream was good. For anyone who's here on my end, check out Kim. She games. She talks about space. A lot of good stuff. We catch up. Mabby Hate, welcome in. Metallic, hello. A Townsy, hello. Aaron. So yeah, I've kind of been off on a tangent right now, but the theme of the stream is I take people's questions, math questions from chat, or just random questions too, I guess, and I do my best to answer them. If there's a question from chat, I'll work on like some homework I have because I'm studying for a master's in applied math. So I've been working on this really annoying problem that I'm not liking in the background. But we've been talking about like maybe a few different things at one time here. So I was just like talking about the classes that I have been taking. Then also there's a book about evolution that someone brought up that I'm going to get back to in a second. The tangent, what an unfamiliar thing to me. Tangential, she's round. Go space as a tourist, but not as an astronaut. I get anxiety just going on an airplane. I could never go to space. Say the meaning of life if you ask nicely. Yeah, it might not be the right answer, but I can sure tell you something. Hey, Skirtle. But down my way to space, nobody will ever forget me. That's true. I mean, yeah. I can't name who was on like the Challenger, I guess though. So maybe I don't know about that. Okay, and then I think it was Orange who brought up this book. I just wanted to read like what the synopsis was. Onizuka or is the only Hawaiian astronaut? Ooh, that's cool. I went to college in Hawaii for my bachelor's. So this book apparently claims the evolution by natural selection is mathematically impossible, which seems surprising. You too? Oh, that's cool. You don't have to say where you went, but I don't care about revealing my personal information. I went to Hawaii Pacific University in Honolulu. So I lived there for a good like 3 years. UA Chilo? Oh, nice. Yeah, I feel like I kind of wasted my time living there because I don't go outside, but it's a pretty cool place to live. I'm probably taking an applied math course next semester. What do you recommend taking since you know my taste? Well, your taste is not applied math, right? So... what are your options? What's been amazing? It's pretty cool. As an undergrad, I never actually once went to the beach. Wow. I mean, I went like a couple times, but not enough. When we were at work, I had a car and went to the beach like weekly. Okay, good. I lived like a probably 20-minute walk from the beach, and I don't think I ever did that walk once, but at least for one of the years I was there. PD, numerical analysis, stats, data analysis. For you, I mean, even for me too, probably. Like I would probably say it depends on how that's like what angle they're taking, but like PDEs are numerical analysis. Like I doubt you would like numerical analysis, but there are a lot of ideas from. I mean, you're kind of like algebra though. Wait, why is this song and why is it playing Frank Sinatra? I gave it the Rolling Stones as like a seed song, and okay, you know that's life. We're letting it roll. Um, That's kind of rough for you, Destin. I don't know. Like numerical analysis, it can be cool because you do borrow a lot of ideas from regular analysis, and so there's some really clever uses of just like ideas from analysis. It's like maybe you could get somewhat interested in that, but you might just want to go for PDs. Even then, those aren't. I can't imagine you're gonna be that interested in them. I don't take the book too seriously. He didn't study math. People have called him a self-described misogynist, racist, anti-Semite, and a few other flavors of asshole. Jeez. A self-described. It's rare to hear people call themselves that. Um, that would explain a lot, though. The last phrase could use some workshopping. Flavors of asshole. No, it's evocative. You know? Sometimes assholes taste one way, sometimes they taste another. To understand the scientific catastrophe that is modern biology. Imagine you're told a man walked from New York City to Los Angeles in under 5 minutes. You don't need to be a scientist statistician to know it's impossible. You need to have a rough idea about how fast the average human walks. Okay. The mittens proof. I guess I would need to see what the actual argument is, but I doubt this is going to be a good one. Gemini 3 Pro audited the book? Okay, buddy. Passed by an accident on the freeway. Reading this thing? It feels like it. A least favorite vegetable. Oh, you're having dinner? Okay, sorry, Tachyon. Okay. Yeah, this probably is not the most serious of books. Or maybe it's trying to be serious, but it's probably not. um okay, so I guess let's read through what Destin's options are here. Here's a more complete list. Applied PDs, methods of applied math, linear algebra applications, applied algebra, mathematical physics, rigorous results in statistical mechanics. Oh, don't do that. Non-equilibrium numerical analysis, numerical solution of PDs, system theory, graph theory, mathematical models of social and policy problems. That sounds sick. I would actually love to take a class like that. Discrete math, introduction to mathematical techniques and operations research, improbability, ergodic theory, financial mathematics. Ooh. Oh yeah, ochre is a tricky one. And hard to agree. Garlic is great. Um, yeah, Dustin, I think of you as someone who generally leans kind of towards algebra. And so, like, I would, like, applied algebra seems like it'd be the one that's the most up your alley. The linear algebra class could be cool. There's a lot of like numerical linear algebra algorithm stuff that I assume you might get into. I don't know. You almost failed probability in stats too. Geez. Tend to lean slash meeting slash seminar last semester. The proof was using Claude AI to formalize math was actually really helpful. Oh, that's kind of interesting. Statistical mechanics could be an entry into probabilistic modeling, I think. Yeah, I mean, I personally would be interested in learning about statistical mechanics one day. But I think that'd probably be the last thing Destin wants to learn about. um, yeah, Destin, I guess I would say the applied PDs, linear algebra, or applied algebra. I don't quite know what applied algebra would entail. But just knowing that, or I was thinking that you prefer algebra, that'll probably be the one you would like the best. It's okra. Like I didn't eat very much of it growing up, but for some people it's pretty common. Um, okay, so for this homework problem, um, there's a right way to do this integral that's really quick. Or basically, the homework assignment is to get an asymptotic expansion, which is sort of like an estimate, but not exactly, for this integral here. And this integral is really hard to do, like, analytically, I guess, or I'm not sure what the right word is, but it's hard to, you can't really integrate this with the usual techniques. It's just too difficult. So the next best thing we can do is an estimate. And there's a right way to do an estimate for an integral of this form. It's called the method of stationary phase. And I did that, and this is the entire problem being solved in like 3 lines. We were specifically told after we were then specifically told not to do this method and to do it a very long and tedious way called the method of steepest descent. And so that's what I've been trying to work through on this stream. You want to do Descens? Yeah, Descent on font. That's a thing in math. It has like a Wikipedia page. I forget what they are. Wait, why did this come back? Go away. Okay, so where I'm at right now in this problem is I have this integral and I need to find an asymptotic expansion for it. We need to do Laplace's method. And in Laplace's method, we're going to take the series for sinh, the first few terms. Oh, wait, we need to do the Taylor series about, are we doing it about 0 or about a maximum? Doomlet, hey, you've officially finished A-level further statistics and math. What should I do now, you think? Well, first off, congrats. What are your options? Like, are you moving on to university, or are you still like, I guess like I'm not sure what else you have available. Oops. Let me grab my. I mean, actually, no. I don't need to grab my notebook. Um, where are these lecture notes? MS in academic counseling. That's kind of been true. Um, there's been a couple of questions about like what classes should I take the last few streams. You still have until the next scholastic year. I'm done with further maths and stats now. I want to move on to self-studying uni level math, which should align more with my major, data science and machine learning. Ooh, okay, that's good information. So you're self-studying, and you want it to align with your major, which is data science and machine learning. Uh, so I'm not the most familiar with machine learning. Actually, I'm not even slightly familiar with machine learning, to be honest. But um, I think linear algebra would be a really safe bet for any type of data science and machine learning. And if you haven't done any linear algebra at all, I mean, I do have some gripes with it as not being maybe the best first introduction. Um, but yeah, I guess I would generally recommend linear algebra as a good place for you to go because I believe like with A level further maths, like you already know the basics of calculus and stuff, so you can kind of get into the. Well, once you learn calculus, there's like a really big breadth of things that you can move into. In linear algebra might be the best one for you. Claude's little brothers and sisters, yeah. Um, eigenvectors and values, diagonalization, matrices, inverses, determinants. Ooh, nice. So that's a lot of the important stuff right there. Yeah. So I personally have done MIT OpenCourseWare for linear algebra with Gilbert String, and there'll be a good amount of stuff that you can probably skip over. I don't know which one is better. But like, um, learning about singular value decomposition would be a really good goal. And it's if you already know diagonalization, you're most of the way there in eigenvalues and eigenvectors. Um, and yeah, sure, that works. Do wood. Um, MIT OCW. String linear algebra. Because I've watched every single one of String's lectures that are up on YouTube. At least for one of these series of courses. Yeah, it's this playlist, I'm pretty sure. So you don't need to like watch all these, but like um like singular value decomposition would be a really good thing to know. And that's going to have some like prerequisites probably. So like you might want to go through and like fill in the gaps before you do that. Or you could start with this and then go back. Oh, really? He does have a textbook. Let me see what you sent as well. Transposing, determine if they weigh 3 inverse. Okay, there's a lot more to linear algebra than just this. Like, I feel like you've maybe learned just the minimum to get to diagonalization. But there's a lot of like baseline stuff that's like will be going on in the background, I guess. That's good to know. It's not like the most important. Like stuff like the null space or span. I didn't see like specifically mentioned. Did your professor explain what is a vector space? Literally as a line where vectors of all sizes on top of each other, starting at the origin, are the elements. My professor did not. No offense to Zach, she was an ed math PhD. A vector space, literally as a line. Well, a vector space is like linear combinations of vectors, right? Like basically the span, like, or wait, sorry, a vector space. Vector space. It's just like the set of elements. Yes. Sorry. uh so I don't think so, does it? But like I don't quite know what that means, to be honest. Can't afford a car, so she named her daughter Alexis. Hey, syntax. Procrastinating all day, playing with Overleaf. I just thought myself I should stop myself from being me and study. Doomwood Overleaf is a website. Uh where it's like Google Docs but for LaTeX. And LaTeX is the thing you use to like type math. If you want to do a good job of it. And so Overleaf isn't the only option for LaTeX, but it's a really convenient one. So if you're interested in like typing up math in a nice way, that's what you would want to learn. All finite dimension vector spaces are inner product spaces. Ooh, I don't know the definition of inner product space. To get on the Overleaf meta. I like it. We got a course for it at my uni. Gives credits. It's a self-study thing. Oh wow, that's cool. I just kind of learned by doing. When I became a research assistant for one of my professors. That's our own definition, but the intuition is what I said. I mean, that's not my intuition for a vector space. Like, I mean, maybe we're saying the same thing in different ways, but like, if I think of like the intuition for like R2 as a vector space, it's just every possible vector with 2 real numbers. But I also like, I don't know, thinking of vectors like that seems like it's not necessarily a good thing. Because like at some point vectors stop being lists of numbers when you study linear algebra and they start being like functions or something else. And that geometric interpretation for what a vector is kind of falls flat on its face. As far as I know. Nowadays types might be a bit better. I've heard someone mention that. I don't know anything about it though. A real vector space with an inner product is called a real inner product space. All finite dimensional vectors are also inner product spaces. Uh, hmm. Okay, you know what? Actually, that would be great, Dessen. So like something that just came up in my asymptotic analysis class is my professor was saying things like freaking that drawing. Um, I'll just like simplify it that e to the x and e to the 2x are linearly independent, and there were a few students who were confused by that statement. Um, so is there a geometric intuition for like um I guess when your vectors are exponential functions? Like to me, I just think about it like I guess with the algebra. Since all n-dimensional vector spaces are isomorphic to Rn, I would assume that Fv to Rn be an isomorphism. As soon as we say isomorphism, I only have like a 1% idea of what's happening. Uh, if it's finite dimensional, I think that makes sense because you can always define your inner product as element-wise multiplication like that. I think it's basically that's saying syntax error. And that would make sense to me if any finite dimensional vector space can have an inner product because of that. Um, in nice words for me, all norms are equivalent in finite dimensions. Okay, I think that's for what syntax is saying. Um, so then, but like, if there is a geometric interpretation for like those, I would be interested to hear because I can't imagine what that would be. Besides, like, I guess you could think about the graphs, but like, I don't know. I think that's kind of lame. Oh, right. I was gonna. I need to remember how Laplace's method works. My professor say where x lives. I guess a real number. So wait, did I? Hmm. I'm getting confused about what to do with this integral now. Um, use definition of linear independence. Put zeros and it gives you zeros. Well, yeah, but that like I wouldn't call what you're saying geometric. Like I don't know. Like in your normal introductory linear algebra class, you learn about like how linear transformations basically angle your regular Cartesian coordinates, and you could get axes that like look like that instead. Um, but like I can't think of an equivalent to this idea of linear transformations when you have things when you have different types of vectors for like an arbitrary like abstract vector, I guess. Like it seems like this interpretation only works for vectors being lists of numbers. I guess that's the kind of thing that I'm trying to get at. Okay, so my A is 0, my B is infinity. Um and my R of T is negative sinh. And the maximum value of negative sinh is on this interval is 0 because I think that it's going off to negative infinity. So we have exactly this case one where the maximum happens at the first endpoint. And lucky us, our maximum is already 0. So we don't have to do that first step. This step I already did. This step is what I was trying to figure out what to do. We do a change of variables, right? Okay. That's what I was missing. So I want to make this sinh into just an S. Because then I can use Watson's lemma. Sinh goes to cosh. Did the music just stop? Or is it just quiet? It's just quiet. This is gonna get a little messy. Because this is gonna become sech y ds equals dy. And we need to get rid of that. Is this gonna be sech of arcsinch? Is that what you're telling me? This is so cursed. Does this simplify? For intuition, they need to intersect after x equals 0 for them to be independent. That would be the geometric intuition. I guess. Um, that's a true statement. Um, I don't know if these lecture notes got posted yet. February 4th. Let me see if the thing I want to, the actual context of what we're working on is here. Okay, so this is the actual like I made a simple example with e to the x and e to the 2x. The actual context where this came up was with second order differential equations. We're talking about monodromy. And I've already forgotten exactly what we were doing with this, but the solutions in the neighborhood of 1 point are just a linear transformation of the solutions in the neighborhood of another point because of analytic continuations. And I guess like when my professor, I should maybe go to our officers and ask this, but the professor like wrote this CK matrix here. I don't even know what these elements would be. Like, are these other functions or are they just numbers? And like, I don't know what the geometric intuition of having these two functions times a matrix is. Oh yeah, no worries, Destin. That's more important. Let me catch up with your comment. There's a beautiful related definition in algebra called space with functions. It's useful to define a ring space. That's a fancy word. Think of the function x squared plus y squared plus 2. Cut it in fourths. Give you a sphere. So a space with these quadratic homogeneous functions gives you the beautiful sphere. That makes exactly a sphere? Wait, x squared plus y squared. Okay. Huh. Maybe I get that. But yeah, anyway, good luck with your practice. Oh yeah, so I want to see Wolfram Alpha, please save me. Does hyperbolic secant of arc cinch simplified? Please tell me it does. They're just numbers? Okay. That would make sense. Oh, it does simplify. Look at that. Hey, Leo. Kinda. Doing a very tedious problem about method of steepest descent right now. Okay, can I get the formula? Arc Method of steepest descent. It's for, I guess I should show you the actual problem. We're trying to get an asymptotic expansion for this integral here. As lambda goes to infinity, it's too hard to, integrate the right way, so we have to, the best we can do is an asymptotic expansion. There's a much better technique to use for a problem like this, but we're specifically not allowed to use it. We have to do it the long and tedious way. And so I'm trying to work through that. K? Who's K? Didn't I record the model theory video on me too? Oh. Okay. I guess you two know each other. That wasn't directed towards me. Right, K theory. Okay, I have heard of that person. So we have arcsinch. Sech is, I guess, 2 over e to the x minus e to the minus x. Okay, now we need to compose these two functions. Oh, this might not be that bad at all. Now that I look at it. Wait, this minus e to the minus x. Am I doing that? I feel like I'm not doing this piece right. I think it's supposed to be more like this. And all I have to do is simplify this. Easy, right? Ugh. Basically, I'm squaring this thing right here. Okay, we get 2x squared plus 2x root x squared plus 1. The 2's cancel. If we factor an x out of the bottom, I'm just getting 1 over x. Well, that's not right. Hmm. I guess I can plug this first up into Wolfram Alpha and see if it comes out to be the same thing. It is 1 over x, so I'm doing something wrong with how I compose them. You know, let me just... I don't know why. I feel that the urge... Okay. That does look like root 1 over 1 plus x squared. Or whatever. Looks like that. Apparently, I don't know how to compose functions. Oh, never mind. What am I looking for? Oh yeah, inverse. Huh. I seriously, like, I can't find what I did wrong. Ah, what did I just do? Okay. Root x squared plus 1. I composed them wrong. I I don't see how. Um I well, there's your problem. I forgot the definition of Kosh. I put a minus where there should have been a plus. Okay. It's a +1. +2. Okay. Well, okay. I think I see the at least part of the tech. Cancel all the 2s. Um, do we factor out? Uh, yes. Okay. Yeah. I see it. We've from the bottom, we factor out a root x squared plus 1, but all tactical like. Pretend this thing is a unit, so that becomes a root x squared plus 1. And then from here, we get just an x. Now these two cancel. Okay. Side mission complete. I'll have to say this is 1 over root s squared plus 1 ds equals dy. When y equals 0, s equals 0. When y equals epsilon, s is sinh epsilon. This took up way too much room. Ugh. Minus lambda s 1 over root s squared plus 1 ds. Okay. Watson's lemma. This function is integrable for sure because the interval is finite. So we don't have to worry about whether it decays fast enough. I don't think it would decay fast enough. So it's good the interval is finite. And we're going to let sigma equals 0. Infinite number of continuous derivatives. I'm pretty sure it does. Are we finding just the leading order term? Yes. So we're going to use this formula right here. It's actually... Should we screenshot it? Sure. This is a little large. This work is taking up too much room. I don't want to get rid of it. Okay. So we just want the leading order term, so we only care about n equals 0. This right here is g. So we're not taking any derivatives, we're just plugging in 0. So that's just 1. This is gamma of 1, which is 1. 0 factorial is 1. So we get just 1 over lambda? What answer are we expecting to get? Something a lot more complicated looking. But this might be okay. Because the complicated looking stuff might come from the thing that I'm delaying until last, which is this C3 contour. So that's going to be a pain to deal with. Okay, so let's think about C5 in the spirit of delaying the discussion on C1 for as long as possible, or on C3. Ah. Okay, so what's happening on C5? It should be really similar to what we just did. X is always pi. Y is going from minus infinity to 0. Oh, that's not it. 0. Okay, so if x equals pi, you zero out as you should. You become -1. So this is going to be the exact same thing. Except a minus sign in front. So it's actually going to cancel. Does that make sense? Can we figure that out intuitively from this integral? I don't want to think about it. Man, I wasted all that work then. I didn't have to. Actually didn't even have to do all this up here. Okay. Yeah, it's good practice. It's good practice. Wait, maybe it's not a waste. These might not. Let's not be too hasty. Okay, this minus sign comes from that minus sign. When y is negative infinity, t is positive infinity. When y is 0, t is 0. I'm reusing t is a bad letter to use. Ugh. So actually, no, I think they won't cancel now that I look at it again. Because we have to flip the bounds. So, okay. I guess by the same work as before. 1 over lambda plus something little o of that. Okay, there's only one piece left of this puzzle. Which is C3. C3 is going to be the trickiest bit. Um, so on C3, we need to do Laplace's method, but with an interior maximum. Is the moral of the story. We need to figure out how to set up this integral. God, I wonder how you make a final for a class where one question takes like 5 hours to do. Okay, so C3 is this piece of the contour here. So I should be using that color. So I think we might need to split up into an upper half and a lower half. So on this contour, I is constant, equal to 1. Okay. So I is sinh x, or sine x cos y. Oh my god, all this work. And we do need to add in a constraint that when 0 is less than or equal to x is less than or equal, well, sure, yeah. Less than or equal to pi over 2, y is greater than 0. And when pi over 2 is less than, well, or equal to, x is less than or equal to pi, y is less than 0. You are both severely underprepared from bachelors. You have another way to explain that some people do my homework in one day. I definitely am underprepared for my bachelor's. I would bet the people who do the homework in one day are a minority, though, at least. I know, I really have a hard time with this, where I always feel like I'm like the most stupid person in the class. But I don't know, like the smart kids always like certain types of smart kids have a way of like sticking out, and like it's really easy to just like focus on them. But I don't know, they're probably not the average student in that class. Yeah, there's been quite a few things we've been talking about in my classes that are we never talked about at all during my bachelor's. Um, so like actually the thing I was just showing before about monodromy. Oh, where was it? I think I closed out of it. But like one of my professors was dropping like open covers and finite subcovers. I never learned about those during my bachelor's. I wasn't even heard of those because of Zach. Welcome back, Gonzo. Yeah, if you want, you can ask it. Do you also have undergraduate students talking words you never heard? I don't interact with too many undergrads. They definitely could though, like especially if they're from like not inside the applied math department, like just the regular math department, or sometimes get students from completely outside math departments in the classes. They definitely could. How to do factor of change? It's a little bit vague. I don't know what that is. Or like that could be a lot of things. Oh, maybe that's a specific thing in AP Physics? Or just in physics? Oh my god. Prodigy School of Sciences? Oh, that's why, so I'm fine. SpongeBob is not in the curriculum. That's a miss. Oh, okay. I just haven't learned it by this name. I know what this is though. Yeah, like, what's your question about it? Irondale, what convinced me to study science math? Um, it's a good question. So, um, I first got interested in math, uh, in senior year of high school. So when you're 17 or 18 years old, uh, I took my first calculus class, and I realized something I was learning in my physics class that didn't use calculus could be explained with calculus, and I noticed that like on my own, and I just got like a nice buzz from feeling like I figured out like a little piece of how the universe works just like using math. Um, and how calculus kind of connects a lot of things that are previously taught to you as disconnected. Um, and so that's what got me interested in kind of math in general. Uh, I got a lot of engineers in my family, and so when I applied to university, I did it like it originally applied as an engineering major, and that's what I got accepted as. Um, Thankfully, because I ended up like changing course into just math, which I like way more. Thankfully, my university's engineering program really sucked. And so I transferred out of it into applied math, just kind of being something that's close to like I didn't really think that much of it to be honest. Um, but yeah, as I took more and more math classes, I ended up liking it more and more, just like for its own sake. And I guess like yeah, for I mean for its own sake, but also because I feel like I'm just learning the language that you use to describe the universe. I guess when I learn more math. Back when math lectures were given in PowerPoint, if I knew I had to see more analysis, I would have not applied to grad school. Oh, yeah, that sucks. I imagine they for like a general like math graduate degree, they probably make you do a little bit of everything. Also, thinking about math or physics was too afraid of becoming a teacher. Now I think I regret. Yeah, I wouldn't go into those to make money. either of those. In my opinion, you should study the thing that you like and not think too hard about the careers. But that's not how everyone wants to live their life. And if you want to study something just for the career prospects, that is your prerogative. It's not what I want to do, though. Money but no satisfaction, yeah. Your first gen for everything. I mean, that's huge, Destin, though, that you're going to grad school as a first generation student. Gonzo, I see you. I'll look at that closer in a second. But yeah, Irindel, so when I graduated with my bachelor's in applied math, I could not get a job with my degree at all. I ended up getting a job that was basically being a human resources person. And so, like you said there, like it paid really well, but it was really freaking boring. I had a really good boss and a really good boss's boss, and that helped keep me around for longer than I would have otherwise, but it was not a fun job. But thanks to that job, I'm also now able to go to grad school, so. This research at Microsoft makes 120,000 starting. If you can get that job, they're going to require like probably 10 years of experience before they pay you that much. And they're going to have a shitload of people applying to all do it. I wasn't switching to math until my senior in high school too, Peach says. I remember math teacher asked what I wanted to do when I got older. I wasn't really sure. When the teacher said I should consider math, next year I personally got super into it, enjoyed stats a lot. That's awesome. Like, that's a fantastic teacher. Hopefully the teacher was actually good at their job, but um that, that that's cool to hear, Peach D. 5 years experience for entry level. Yeah. For me, it was because it's the only way to communicate to people 10,000 years from now. And the same time ago, I could understand what Euclid thought or Galois was thinking when he developed his theory. I mean, that's interesting. That's an interesting point. I'd never heard that perspective on math. I wouldn't say it's the only way to communicate. Like, people 10,000 years from now will be able to understand the English that we're speaking now. But there is like a connection where, like, regardless of cultural background and language, like, we can always understand the math. I guess the notation has changed, but I think of like it's like for like modern math. If I read some math paper in French, I can often get the gist of it just by seeing what the math symbols are. And I can see like a similar argument for like going back historically. Dream about going to uni again this time, doing what I like. I hope you have that opportunity, Irindel. I can afford to never earn a single dime for the rest of my life. Well, yeah, Irindel, you should get like 10 degrees then, just for the hell of it. As long as you can afford it, I guess, but it's a great place to be in life. And sorry, guys, I promise I'll get to this in a second. It's one of my favorite aspects of the timelessness of it. Yeah. Because I'm sure even with like Euclid's elements or something, even if you don't know notation, you could probably reverse engineer it from the diagrams. For my question, use F equals G. Okay, yeah. M1, M2 over R squared. Okay. Prove the gravitational field is approximately constant by comparing the G value at Denver to the G value of Miami. Miami is located at sea level. Denver at 63 or 1.6 kilometers. Okay. This is a neat question. Let me I want to figure out a good way to phrase this. Newton invented calculus motion law. Then he turned 26? Damn, that's... I mean, you... Newton's one of the smartest people of all time, though. You probably shouldn't compare yourself to him. The Earth is round and uniformly dense. Oh, that's true, Yarndell. Yeah, we are doing that here. You worked at Staples. Offered a managerial position, opened your eyes. Oh man, 50K. Hopefully it's a low cost of living area if they're only offering that. They're gonna be a math teacher, then you met algebra. It was all... And the rest was all history from there. I guess we can actually just plug in some numbers here. Imagine that's because you get compared to. True. Yeah. I think the cleanest way to do this would be to calculate. We'll start with Miami. So let's do F sub M. We don't care about... The only thing that's changing is the distance. So we can keep G, M1, and M2 as whatever they happen to be. Because the thing we really care about is R squared. So 6,300 squared for Miami. And Denver, or Devnever, G, M1, M2 over 6301.6 squared. And so it doesn't matter which one we do over which. Oh, that's a good point. I mean, actually, no, we don't need to convert it to meters because we haven't chosen a value for G yet. But yeah, if you're using this equation in general, you should make sure to convert these distances to meters first. It's not important for this question, though. And so another thing that doesn't matter is what I'm going to do next is I'm going to take F sub M and divide it by F sub D. You could do the other direction too, or like you could do F sub D over F sub M, and it's going to be basically the same argument. And it'll be more clear why at the end here. 6301.6 squared. Yeah, and so you could just have set these constants to 1 right off the bat. If you prefer to do it that way, do it that way. I'm doing it this way just because they're about to become 1 anyway. So I'll kind of write out all the steps here. Division by a fraction means multiplying by the reciprocal. And now the great thing that happens is these G, M1, M2s cancel. And of course, you could have just set them to 1 at the very start because that cancellation will always happen when you do this technique. And so what we end up with is 6301.6 squared over 6300 squared. And so let's plug that into a calculator. Radio 6300 squared. So yeah, we get slightly different numbers, but for all intents and purposes, like the result is the same here. One, two, three zeros, was it? Yeah. So whether that's a 5 or a 2, like we can make the exact same argument. The point of this number is basically 1. Like this part out here is insignificant. So if you divide two numbers and you get 1, it means they're basically the same number. If you get exactly 1, they are the exact same number, but it means what we've shown is that the force of gravity at Miami is essentially the same as the force of gravity at Denver. And that's what that's basically like what they were asking us to prove. So I hope that makes sense, Gonzo. Hey, BR Gaming. Thought calc was the only math since I was taking it for about 3 years of calculus and or related stuff. Ooh. I mean, I wouldn't have minded that, but yeah, it probably for an algebra that wasn't too fun. Oh, I don't know what the compliment. Oh, the Ed Sheeran thing. No, the Ed Sheeran is just like a joke where people say that I look like him, and I definitely don't mind being compared with Ed Sheeran. Makes sense. Okay, awesome. You see, like this style of question is like a little bit like trickier. If they just said like you doubled one of the masses, it would have been a lot quicker. Dawn is approximately Ed Sheeran. Well, I think Ed Sheeran is approximately Dawn. I think it's the other way around. Okay, unless there's another question, we're gonna go back to steeply descending into madness. So my e to the x and e to the 2x are linearly independent. We need karaoke for Ed Sheeran songs. I mean, that could be done. What you do with the Newton's law equations, make F into G. I'm not sure what you mean. Like, Gonzo, like, it is a pretty common thing when you're doing calculations for other things in physics. Like, if you know that the force is gravity, or like, you know, if you know like this law of gravitation, we also know that force is equal to mass times acceleration. It'll be one of these masses. I'm just going to choose M1. And then like that mass will cancel with that mass. Oh, and I guess A is, I mean, so you get acceleration is equal to that. But also this is just the acceleration due to gravity, so we give it a special name G. Oh, that's what you did. Uh, oh, there you go, Jed. You still have the clip. The Wronskian is e to the 3x, which is never 0. Well, yeah, Zach, I mean, you might have a problem with this, or maybe you always have a thought on it, but earlier I was arguing that the geometric kind of visual explanation that you get in your normal introduction to linear algebra class, the phrase I used was it falls flat on its face when you do more, when your vectors become more abstract. And my example of that was e to the x and e to the 2x. Like, I don't know how you, like, how do you explain a linear transformation on those functions geometrically, I guess? Or it's like, the image I'm thinking of, like, in your normal introduction to linear algebra class, you have like the normal Cartesian coordinates, and then you multiply it by a matrix as a linear transformation, and you get tilted axes and all that like fun stuff. Yeah, that's why Dustin was saying that, because I was saying that there isn't something like that, but I don't actually know that, because I don't know linear algebra that deeply. Clips of warnings: be careful what you ask for. I mean, that's not a geometric intuition. I don't know. Maybe the Wronskian has a geometric intuition, but yeah. As that's a fun question. Once, if you encompass the Earth with a rope tightly, extend an additional 1 meter. Oh, I've seen. We did that calculation in one of my physics classes, I think. I remember seeing that, or maybe we talked about it on stream. Um, Tell me anything algebraic, and I'll tell you geometric intuition. Yeah, let me catch up with what Gonzo was saying, and then I want to look into I want to look up an explanation of Earendell's question. I could figure it out for myself, but I don't feel like it. Anyway, g equals 1 over 1.025. Take that x by 100. I'm not sure what that last step means, to be honest, Gonzo, but x by 100. Since you know high-level math, would you be willing to check an equation I cooked up hoping to get published? It's quantum mechanics cosmology. You can pose it if you want. I don't know if I can help you with it. Okay, Earendell's question. Oh, wow, this has a Wikipedia page. String girdling Earth. Oh wait, this is the reverse of the question, isn't it? This is saying we're increasing the gap and asking what the circumference is. Yeah, this isn't quite the same question. Uh, Jed is saying circumference equals pi times diameter. C, circumference of the Earth. D is diameter. C equals pi times d. Yeah, I guess we would cut the diameter by 2, or... Okay, wait. I guess we're gonna work it out. So yeah, so picking up with Jed's work, C is circumference of the Earth. We're asking, we want to quantify... We want to figure out what the new diameter is, and we can use that to figure out what the gap is. Every additional unit circumference increases the diameter by 1 over pi. I guess, yeah. Yeah, that will be right. Because you divide out the pi. It's equal to dn. But then c over pi is diameter. Um, so yeah, just 1 over 2 pi? I think I agree with that. Yeah, Jed. Um, so that'd be like a few feet, I think. Wait, no. Smaller, small. No, no, oh my god, it's a few feet. No. Be like a few inches, maybe. Total multiverse is the sum of all possible branches, each weighted by action each branch. Uh, yeah, Gonzo. I don't know. I don't know if I can help you with that. There's a lot going on there. Yeah, I think Jed's right that the additional gap should be 1 over 2 pi. So we can actually get that. It's like whatever. You don't go outside anymore. Okay, me neither. That's 0.16 of a meter. Okay. Um, adding. Yeah, I think I agree with that. And and or yeah, I guess it doesn't have to be an integer. It could be a decimal too, and I think the formula still works. She does not depend on the Earth's radius. That's why I was hesitating so much. I thought we'd have to do something extra. But we have that because circumference is linear with radius. If we were talking about like area, it would have been different. I think that's the key thing here. When Gonzo graduates, principal will give Gonzo high school diploma. Gonzo was free. You can do your quantum mechanics all you want after. Visual group theory talks a bit about it. Ooh, nice. Geometry of the primes. Um, just look at how long I've been streaming. This last part of the contour is like the final boss of this problem. Also, wait, I just remember that Stookie typed something. I don't know if I acknowledged it, but hi, Stookie. You're still listening. um, C3 is the actual like hard part of this problem. It took me 2 full pages plus 2.5 pages just to get to the hard part of the problem. Attack with clever substitution, minus 100 HP. It is crazy how much of math is just changes of variables. Like most of this asymptotic analysis stuff has been like a change of variables is like the engine behind it all. You just always make everything a Gaussian function, or just like instead of a Gaussian, just like an e to the minus x. Um, so this gives us the parameterization. This is math. I barely see numbers. Can't wait until it starts algebra. Oh, yeah, that's always a rude awakening. Arc-Cosh of cosecant x. This is definitely my favorite function. When x is between 0 and pi over 2, and minus arc-Cosh CSC. When pi over 2 is less than x is less than pi. Okay, so did the music just stop? It did. We got to the end of the playlist. Which means we're just going to regular synthwave. Because I don't feel like figuring out another song. Song radio. Okay. So, the integral in C3. My algebra teacher for being my first teacher made me like math. Oh, good. A good teacher makes such a big difference. You can do that, Arundel. It'll play in 1 minute and 10 seconds. Assuming you approve the Riemann hypothesis, then by the prime function, there should be a relationship with the shape of this function. Okay. What did not help? The learning glass? Oh, yeah. I don't like those things. Oh my god. Oh. Oh no. We're gonna have Cinch of Arc-Kosh of cosecant. Oh, what a function that is. This will be Kosh of arc Kosh, so we get a nice little cancellation there. Cinch of arc Kosh, that should simplify. Sin x. Oh, of course, the imaginary component is going to be constant. Of course it evaluates to 1, because that's what the contour was. ds. Okay. Okay, Gonzo. Yeah, fair enough. Okay, I'm going to make Wolfram Alpha simplify cinch of arc Kosh for me. If you call that simpler, yeah. Ooh, wait. This seems like a bit of a domain issue. What about when x is between -1 and 1? Uh... Oh, crap. Does throwing in the cosecant fix anything by any chance? They need some work. I think it's perfect the way it is. Oh, it does somehow fix things. Oh, of course it's going to look like that. That function is root cosecant squared -1. I should have... Actually, I guess I don't know if I should have known that or not. E to the lambda I. 0 to pi over 2. E. So we have a minus sign there. Minus lambda cosine x root cosecant squared x -1 dx. Okay. What a function this is. That sine and cosine could be invertible given an appropriate bound. So Trolley-Calc students at university with sine of arc sine 30 or of 30 or 30 times or something. I don't even want to, I don't even want to think about that right now. I know that there's issues where like sine of arcsine isn't necessarily arcsine of sine. I forget the exact reason. Okay, we need to think about, so this function at pi over 2, I'm pretty sure is 0. Yes. Yes. And at 0, it's blowing up to infinity. So we want to, we care about the area around, so this is e to a negative number. The maximum value of the integrand comes when x is around pi over 2. So we want to split this integral up into an integral from 0 to pi over 2 minus epsilon, I guess. Using the complement of 35, supplement of 125. So idempotent? Idempotent? I don't know how you say that word. I've seen it before. It weirds me out. The complement of, I mean, I guess it depends, like the complement of 35, wouldn't that depend on the operation you're talking about? Like it could be negative 35 or 1 over 35 or something. I don't know what supplement would be. Oh, in geometry. Okay, that makes sense. Okay, I really don't feel like justifying because I feel like I've done this calculation a bajillion times. You would bound it above by that value and then find exponential decay. So this is bow, and I'm not talking about the food. I'm talking about beyond all orders. I wish I had bow. This... I feel like we need to do a change of variables, but it should theoretically be Watson's lemma. Um... Oh, you know what? This is an even function. I could actually I don't even need to necessarily worry about that. What I really want to do is just shift the bounds. I can always reverse them by sticking a negative sign in front. The complement of 35 is 35. Oh. Yeah, the symmetry is so important for integrals. Um, so I think if I let u equals pi over 2 minus x, does this accomplish everything I want in my hopes and dreams? I want it to like flip the bounds and shift the bounds so it's 0 to epsilon. When x is pi over 2, u is 0. When x is pi over 2 minus epsilon, u is epsilon. Cosine of pi over 2 minus x, surely that's sine. And don't call me Shirley. Uh, it sure is. Cosecant of pi over 2 minus x. Who the heck knows? It actually is secant. You had one job, Dessen. Unbelievable. um how does sine of secant or this use of shouldn't have changed anything fundamentally, but let me just check how this function looks because I want to see. Theoretically, we should be able to Watson's lemma it up now. Uh, wait. Oh, wait. No, wait. Okay, no. I'm trying to figure out if I did something stupid or not. No, I think I'm okay. Mm. I think I'm okay. Uh, couldn't really tell you for sure. Um, if I want to Watson's lemma, how did I do it with the other one? I mean, what was the plus x minus x trick that I did, or did that not end up working? It might not have ended up working. Oops. I don't know, man. Um, oh, wait. I might have been supposed to be doing Laplace's method. I think I might have need to get the power series for this thing first. You know, okay. I might need to just take a break as an end the stream. I did literally just hit the 4 hour mark right now, too. I know what I just did here was the right play. I'm gonna figure it out later. I think this is a good time to end stream. Okay, so I have too many tabs open. Anyways, here on YouTube, thanks for being here. See you later, YouTube.